Hi everyone, in this video we will solve problem 1.11 from the book Applied Thermodynamics Mechanical and Interior Strokes from chapter 1. Here is the statement of the problem 11. A steam turbine receives steam flow of 1.35 kg per second and the power output is 500 kilowatt. The heat loss from the casing negligible. Calculate the change of specific enthalpy across the turbine when the velocity at the entrance and exit and the difference in elevations are negligible. So this is the first case, while in second case, the change of specific enthalpy across the turbine need to find when the velocity at the entrance is 60 meter per second, velocity at exit is 60 meter per second, and the inlet pipe is 3 meter above exhaust pipes. These are the answers that we will get at the end. So let me draw first the schematic diagram of the steam turbine, then we will move towards its solution. This is the steam turbine, this is the inlet, this is the outlet. The steam inlet taken place at state point 1 and then exit at state point 2 and give the work output at the shaft of the turbine, that is W. So the given data: mass flow rate of the steam, that is given 1.35 kg per second, or output of the turbine, that is P, it is equal to m dot W, and it is 50 minus 50 kilowatt. The negative sign means that give the power output. That's why I'm putting here the negative sign. So there is two cases. In first cases, we need to find enthalpy, and in second case we need to find a specific enthalpy and different condition is given. So in first case, enthalpy change is required to find. From the steady flow equations, I am writing the steady flow equations, that is equal to the steady flow energy equations. C1 square divided 2 means velocity at the inlet is the velocity at the exit, and these are the elevation at inlet and outlet. So the elevation at inlet and outlet in the first conditions is 0, and also the velocity at the entrance and exit is also 0. The heat transfer, the heat loss from the casing is negligible, so this is also 0. I can say that mass flow rate is equal to, so H1, this is H1, and this term is shift to that side, it become minus H2, and this is plus P, power of the turbine output. When it shift to the right side, it become minus. Now just put its value, minus into minus 500 divided with mass flow rate both side, and also divided here, you will get the change in entropy, that is 500 divided by 1.35. After solving, you will get change in enthalpy, that is equal to 370 kilojoule per kg. This is our enthalpy in the first case. Come to the second case. Again, write the steady flow energy equations and then put the required value that is given. So what is C1? First I am writing, that is 60 meter per second. Velocity at exit C2, that is 360 meter per second, and the inlet pipe is 3 meter above the exhaust pipe. So it means that Z1 minus Z2, that is equal to change in elevations, and it is equal to 3 meter. If these conditions are given, then we need to find the specific enthalpy. Now apply the steady energy equations. Now rearrange these equations for change in enthalpy. So I can say that this change in enthalpy that is equal to mass flow rate into H1, and this term will shift to that side, it become minus H2, and this whole terms will shift to the right side, it become minus. So I can write here minus P. Q is 0 because negligible heat transfer, then plus mass flow rate, then because this side is shift to that side, now it is C2 square divided by 2, C2 square minus, this will shift to the right side, C1 square divided by 2, and plus G Z2 minus Z1. Now divide with mass flow rate. This will be cancelled out with this, and this will be cancelled out with this. So the change in entropy H1 minus H2 is equal to, put the values, our output, that is, so this is also minus, so minus minus become plus 35 plus C2, that is 360 square minus 60 square divided by 2, and also we will divide with 1000 to convert into kilo, plus G value, that is 9.81, Z2 minus Z1. We have given the value Z1 minus Z2, it is equal to 3 meter. If you interchange this in term of Z2 minus Z1, it become minus 3 meter. So after solving each terms calculators, you will get this value H1 minus H2. This will give you 370 kilojoule, plus this will give you 63 kilojoule, and this will give you 0.029 kilojoule. So after solving, you will get the change in entropy in these conditions. It will give you 433 kilojoule per kg. And this is our final answer. I hope you understand. If still in confusion, you can ask in the comment section. Please subscribe my channel if you haven't subscribed yet, and also share with your friends and colleagues.